All right, remember a function, we've done linear functions already. A function, there are two there's an x and a y. In linear functions, we were graphing on the xy axis, and we were finding when x equals something, what does y equal? Well, today we're getting into quadratic functions, which is the graph of a parabola. A parabola is like a giant U. Okay? Now, there are specific things that each piece of a quadratic function tells us about a parabola. And then we're going to get into how can we use parabolas in everyday life. And how do business people use these types of things. Okay. First thing is, in a quadratic formula, you have an x squared term. There has to be an x squared term. There does not necessarily have to be an x term. Okay? The coefficient of x squared is a. The coefficient of x is b. And the constant term is labeled c. It's important to know that because we're going to be using those variables in specific little formulas. The sign of a, which is your x squared term, it's the coefficient of your x squared term, tells us whether our parabola opens up or down.
That's the V-shaped parabola?
It's not a v, it's a u. Okay? The v is an absolute value function. This is in the shape of a u. It's close. Okay? But not really, because that had a lot of other stuff involved. So let's just take a guess. If the x squared term is positive, do you think it opens up or down? Yay. Good job. Okay. We are going to work specifically on this function, so I would write it really big. Okay? Because we're going to be learning all the things that we need to know to be able to graph a quadratic function. Write it big so you only have to write it once. F of x, a function of x. Somebody remind me, what is f of x the same thing as? Y. Equals 2x squared plus 4x minus 9. What is a?
2.
2. What is b?
4.
What is c?
-9.
Very good. The direction of opening of this specific parabola, since a is positive, is up. This parabola opens up. Okay? And all I have to do to figure that out is look at the sign of the first term. That's all I have to do. The x squared term. No calculations involved, just using my eyes. The next thing we're going to find is our axis of symmetry. When we were discussing properties, we had the symmetric property. And if you recall, I gave the illustration of trying to draw a butterfly. And no matter how hard you try, you can never seem to get that other half to be the same. But if you fold your paper in half and trace over one side, then it's perfect, right? Well, the axis of symmetry is the middle of your parabola. It's like that fold line. It's a vertical line splitting the parabola into two halves. Now, when we were graphing lines, we said there is a specific equation that is for a vertical line. Does anybody remember what that is? A vertical line.
0.
No.
X equals.
X equals whatever. Okay, y equals is a horizontal line. Okay? So, if we're going to be looking for an axis of symmetry, it's going to be a vertical line, and it's going to look like x equals and a number. Okay? Here is a picture of what your axis of symmetry would look like. You're going to have a parabola. We already said this one's opening up.
That's x equals whatever.
Yes. Okay, this axis is a vertical line, and we're about to find out exactly where it sits. Whenever we're graphing, we would use a dotted or broken line to show us where the center of this thing lies. Okay? Now, the axis of symmetry is found this way. X equals negative b over 2a. Well, where do I find b?
Equation.
in the equation. It's the coefficient of your x term. And where do you find a? It's the coefficient of your x squared term. So you're actually looking for numbers in the equation to plug into this to find out where your axis of symmetry sits. All right, so we are going to find the axis of symmetry for this specific function. We already said a is 2, b is 4. So plugging those into the negative b over 2a, negative of 4 over 2 times a, which was 2, and then we work it out and we get an answer.
What if it was -4? Then would it be a positive?
Then it would become positive 4. It's the negative of whatever that is. The opposite is the same thing. Okay? So this axis of symmetry sits at x equals what? -1. So already we know that we have a parabola opening up, and now we know that the center of this parabola is shifted to the right or the left of the y-axis. To the left of the y-axis. Okay, because the axis is the center of the parabola. The next thing we need to find is where is the vertex on this thing? Because we know it opens up, we know it's sitting to the left of the y-axis, but is it like down low or is it up high? Where is it? So we try to find the vertex, which is the point where the axis of symmetry crosses the parabola. God bless you. Hurley, wake up. Okay, so we had a picture of our parabola. You should have already drawn that. Go back to your picture. The vertex is where those two things meet. Okay, now this is an actual point on a graph, so we are going to be looking for an x and a y value. We already know x. Exactly. Because this vertical line is sitting on x. So we don't have to figure anything out for x. We already know it. The coordinate of the x coordinate is found by -b over 2a. Does that look familiar? Yes, that's exactly what we did to find the axis of symmetry. You've already found it. Okay? X equals -1.
Is it always going to be that way?
Yes. It is always going to be that way. Okay. Here we go. We already did this. Don't write this down. You already have it. Our thing, x coordinate of the vertex, -b over 2a. We said x was equal to -1. Okay, so how do we find the y coordinate? Well, now that we know what x is, we just plug it in. Because remember, f of x is the same thing as y. So once you know your x coordinate, then you simply plug it into your function, and you figure out what y is when x equals -1. Okay? 2 times x is -1 squared. Plus 4 times x, 4 times -1. Minus 9.
That gives you your y.
That gives you the y coordinate of your vertex. All right, well, let's figure this out. -1 squared is what? +1. And 2 times 1 is 2. 4 times -1 is -4. And then we have -9. What does this give you? -11. So, your vertex is at -1, -11. Okay, so let's talk about what we know about this parabola.